charge should be 0.
0.
Yeah. So one point is there. Suppose here is a charge Q1 and here is a point charge Q2, and this is the line joining between these two charges. Okay, and suppose these are positive charges, both are positive charges, both are positive charges. If they are positive charges, so force or due to this charge, force due to this charge on this charge will be in this direction, and I will represent this force as force on charge 2 due to charge 1. And again, due to this charge, if I want to find the direction of force, then this will be the direction of force because they both are positive charges. So I am writing it F force due on charge 1 due to charge 2. This can be a condition.
Yes.
This is my method. Actually, I write the force like this, and I find writing the force like this will be easier in calculating the force. Suppose if there are two charges here, and here is charge this is a position A, this is position B, and here are a 2 coulomb, here is a 2 coulomb of charge, here is a 3 coulomb of charge. They both are positive charge. You can take one charge as negative. So if I want to find the direction of force, here if I want to find the direction of force, the direction of force will be like this. On this charge, the direction of force will be like this, or on this charge, the direction of force will be like this. So I will represent this force on charge at A due to charge at B, and this is force on charge B due to charge A. This is my way of representation. Okay. So I will take this question. This is our question. The question says 3 equally charged small bodies. First, equally charged. You can take negative charged bodies, positive charged bodies, but the charges on those small bodies should be same. Small objects you can consider is like this is the small object, and this small object have the charge. So you can say the question says that there are 3 point charges. Okay, there are 3 point charges. Small object means you can consider small objects with charges. You can consider that as point charge. Are placed as shown in figure. This is the figure given. The object A exert object A. Here is an object A. This is an object. Here is another object. Means you can imagine this as here is a point charge, here is a point charge, and here is a point charge. So I am supposing here is a point charge Q is placed, and here is a point charge Q is placed. Here also a point charge Q is placed. This is I am supposing this. You can consider according to yourself, because in question it is given that the magnitude of charge is same, means equally charged. This body A is equally charged with Q, body B is equally charged with Q, body C is equally charged with. Now I will use this concept. They are saying force on object B, the object A exerts, here the object A exerts, this object A exerts force on B. So direction of force I can write like this.
Yes.
And how I will write? Force on B due to A. Okay, fine. And this FBA is given to us. Okay. Okay. There is any problem, Bhumi? Hello? Hello, am I audible?
Hello.
Actually, I think your internet connection is not good. Not okay. Am I audible? Hello?
Hello.
Am I audible now?
Yes, I got disconnected for a second because of
Okay, okay, no problem. So this is FBA is given.
Yes.
Given na? This is given.
Yes, sir.
This is 3 into 10 to the
To
power
the
minus
negative
6.
6 Newton.
This is given. And now see the first question. See the first answer. They are asking, what electric force does C exerts on V? This C exerts on V means the direction of force will be in this direction. And I can represent this, the force on V due to C. I can represent this. And we have to find F, P, C. So for solving this question, what I will do? First, I will write the expression for FBA. FBA is given, but I am writing the expression FBA. So what is the value of FBA? This is B and this is A.
FB is 3 into 10 to the power negative 6.
Yeah, this is okay, but if I want to write this in form of Q and Q, like I can write K, Q into Q na?
Yes.
Because
both
see
are Q.
See here, I want to find the force in between A and B. So here is a charge Q, here is a charge Q. So K Q1 into Q2 means K Q square and divided by square of distance between them. And
yes.
this is 2 centimeter. So I can write this 2 into 10 to the power minus 2 meter. And this will be square. Because 1 centimeter is equal to 1 into 10 to the power minus 2 meter. And this FBA is given to us. The value of FBA is given to us as
3 into 10 to the power negative 6.
Yeah. So from here, I am finding the value of KQ square. I am finding kq square. So this will be 3 into 10 to the power minus 6, and I will multiply this with this. So I can write this. What will become? What will this become? This will become 4 into 10 to the power minus 4 after squaring.
Yes.
So it will become 12 into 10 to the power minus 10. So this is the value of kq square. So I have find kq square as 12 into 10 to the power minus 10, and this is our equation 1. Why I have done this? You will see why I have done this. So they are asking to find FBC. FBC. So if I want to write the expression for FBC, what will I write? K Q into Q, KQ square divided by 1 into 10 to the power minus 2 square. Okay, because the distance between two charges is. Bhumi, are you getting my points or not?
Yes, sir.
Now I am writing the force between this B and C. B and C. For B and C, I will write FBC. FBC, I will write K Q into Q, and the divided by the distance between them, square of distance between them. So this is Q is KQ square divided by 1 into 10 to the power minus 2. This is square. Okay. And we know the value of KQ square. Now I will put the value of KQ square here directly. Put the value of KQ square here. So we will get 12 into 10 to the power minus 10 divided by, this will become 10 to the power minus 4. Bhumi, now please tell me the answer. After this, can you solve this?
Yes, sir.
Please solve. This will become 12 into 10 to the power. This will be 10 to the power minus 10. And when this minus power goes in the numerator, it will become plus power. Okay. So from here I can write 12 into, this will be plus 4. So do you know the addition of power, how to add the powers? Like I am saying this is 5 square into 5 cube. So this will become 5, and we will add the power. This will become 5 to the power 5. Suppose
Yes.
this is 5 3 and multiplied by 5 minus 1. So I will write 5 3 minus 1 into 2. So same thing I will do here. I will write 10 and minus 10 plus 4. Minus 10 plus 4 equal to minus 6.
6.
So 10 to the power minus 6 Newton. So we have FBC is equal to 12 into 10 to the power minus 6. And this is our first answer. This is our first answer.
So can I copy it first?
Okay, no problem. You can copy. This question is very good question, I think.
And this is based on the equilibrium, right?
No. This is not.
Or is it just like random question?
This is just like a random question, because I want to tell you how to represent the forces. Okay, and after that there will be a question which is purely based on the equilibrium. Purely based on the equilibrium.
Okay. So I wrote this.
Okay. Actually, this is just a warm-up question, you can say, for the next question. So have you understood now how I have solved this question?
Yes.
I have done nothing new. I have
Yeah,
done
you
nothing
just
new.
put the formula of
Yeah, yeah.
the to find what the force on B due to A.
FBA means FBA. If I say what is FBA,
Force on B due to A. Like, yeah,
good.
I know that. Yes, sir, I wrote this.
Now completed now.
Yes, sir.
Okay. So let us move to the second part of the question. The second part of the what is the second part? What is the net force on B? So here is the net force. Now this is the net force. Can I do like this? So now you should only see the B, point B. This is point B. Okay, we will draw this again. They are asking the net force on the body B now. So this is the body B, and there are two forces on this body. So second part of the question is net force on B. So B is like this. Here is one force, and here is one force. In this direction, the force is FBA, and in this direction, FBC. You can see here also FBC. And we have both the forces. We have both the forces.
Yes.
We have FBC. FBC is 12 into 10 to the power minus 6 Newton. And we have this also BA, 3 into 10 to the power minus 6 Newton. Now, Bhumi, here you have to apply the vector addition. There are two vectors which are acting in opposite direction. So what will be the resultant? What will be the resultant? Means what will be the net force? Net force at point at B. I have told you na, like this. You can see here. Like here. Uh, like here. There are two forces now. This is 10 Newton in this direction. This is 5 Newton in this direction. And I want to calculate the F net because they are in opposite direction. So what I have done here, I have simply subtract the forces to find the net force. Okay.
Yes.
So that's why we have studied this story. This story. That's why we are learning the vectors and all that things. Now it's time to use these things. So here are two vectors which are acting in opposite direction. So I will find the net force by simply subtracting them. FBC minus FBA. So what is FBC, Bhumi?
12 into 10 to the power negative 6. FP is 3 into 10 to the power negative 6.
So what will be the answer of this? What will be the answer of this?
For the powers, you're gonna plus because it's minus minus.
No, actually, what I am doing, you can do one thing. See here and see here. 10 to the power 6 is common. So take 10 to the power minus 6 common.
We
Okay,
can take
now,
common things common and then put the others in the bracket.
yeah, it will be 12 minus 3. So what will be the answer now? 12 minus 3, 9 into 10 to the power minus 6 meter.
Okay.
This is
Yes.
the net force on B. This is the net force. This is our final answer. So please revise this question at your home after the class.
Okay. Yes, sir.
So now we have a question of equilibrium. We have a question of equilibrium. Very easy question. So this is the question now. The question says, first try to read the question very carefully. Okay, when we are solving the question. Okay, fine. Two identical charges Q each are kept at a distance R from each other. So what I am going to do, there are two charges Q, two identical charges means two charges, and they are separated by a distance
R.
R. Okay, they are separated by a distance R. So they are saying a third charge Q is placed on the line joining the above two charges such that all the three
Charges are
charges
in
are in equilibrium.
equilibrium.
So now the story is very different. Why the story is different? Let's see. We have solved here a question. They are only asking about the equilibrium of only one charge here. Okay, so that the charge Q means they are talking about, they are saying that Q should be at equilibrium, only one charge should be at equilibrium, but here they are saying that all the three charges should be in equilibrium. So we have to put the charge. Okay, and we are free to put the charge. If you want to put the charge in between, if you want to put the charge here, if you want to put the charge here. So there are two types of charges, plus Q charge and minus Q charge. Okay, so suppose I am taking a plus Q charge first. Okay, putting a plus Q charge here in the middle. So please tell me, so the direction of force due to this charge at 1, I am saying this is position 1 and this is position 2. Okay, so the force on, and this is position 3. This is position 1. The Q charge is placed at position 1 and the plus Q charge, this is also positive charge, this is also positive charge. So the direction of force due to this charge will be like in this direction because they both are positive charge and they both will repel each other. So I am writing, how I will write? Force on charge 3 due to charge 1. Okay.
Yes.
Now due to charge as at 2, this is also positive, this is also positive, means the direction of force will be like this. So I am writing force on charge 3 due to charge 2. So this charge can be in equilibrium. Why? Because two forces are acting in opposite direction. So I am writing here this charge can be okay. No need of writing this. So now check this charge whether this charge will be equilibrium or not. Now so please tell me due to this charge what will be the direction of force here in this direction, because they are positive charges, and I will represent this force on charge 1 due to
Due to
charge
3.
at 3,
3.
and due to this charge the direction of force will be in this direction, again in this direction,
Yes.
and I am representing this force on charge 1 due to charge 2. Force on charge 1 due to charge 2. So means this charge, here you can see the direction of two forces is same. The direction of two forces is same. So this charge q will never be in equilibrium. For equilibrium, two charges should be in opposite direction. Okay. I have told you this earlier. Like here I have told you. This charge can be in equilibrium, and like you can see here, this body is in equilibrium. Here are two opposite forces. Means this is in equilibrium, and this A body is not in body A not in equilibrium. Why? Because the forces are in same direction. Same is the case here. Two forces are in same direction, so charge q cannot be in equilibrium. And same is the case for this charge. What is the value, what is the direction of force due to this charge on this charge?
On
Force on 2
2
due to
due
3.
to 3.
And again, due to this charge at 1, I can write force on 2 due to 1. So here also the direction of two forces is same. So this charge q cannot be in equilibrium. So means if I am placing a plus q charge, this charge can be in equilibrium, but other two charges cannot be in equilibrium. So we cannot choose a positive charge. Okay, we cannot choose a positive charge. So other option is to place a negative charge here. Here what I was doing, placing plus q charge in between, okay, in between 1 and 2. So this idea failed. I am writing here in bracket this charge can never in equilibrium because both forces are in same direction. Are in same direction. This charge can be in equilibrium. Can be in equilibrium because forces are in opposite direction. But what we want, same is the case for this charge. But what we want that all the three charges should be in equilibrium. All the three charges should be in equilibrium. Now I am placing a negative charge. This is charge Q. This was charge Q and this was charge Q. And this is the line joining it in between these two charges. And now I am placing a negative charge in between two. And we will see whether all the three charges will be in equilibrium or not. And I am supposing this as position 1, this is position 3, and this is position 2. Now, for checking the equilibrium, we have to check whether the forces are equal or not. So now I am checking the direction and magnitude of force on this. Give me a minute. Please give me 1 minute. So, if I want to find the force on this charge, the direction of force will be here. This is positive charge. This is the positive charge. So direction of force will be like in this direction. And this will be force on charge 3 due to charge 1. And due to this charge, the force will be in this direction because this is negative and this is positive, and this will be F3 too. So this charge can be in equilibrium because there are two opposite forces. Now let's see for this charge. So due to this charge minus Q, force on this charge will be in this direction. Sorry, not in this direction. In this direction. Due to this charge, the force will be in this direction, na Bhumi?
Yes, sir.
Because they are negative charges. Because they are both are negative charges. So how I will write this? I will write this force on charge 2 due to charge 3. And due to this charge, force on this charge will be in this direction because they are positive charges in this direction. See these charges. So force will be like force on charge 2 due to charge 1. So now this charge can be in equilibrium because why? Because forces are opposite in direction, can be in equilibrium. Now same is the case for this charge. Due to this charge, the force on charge 1 due to charge 3, and this will be the force on charge 1 due to charge 2. Don't get confused. Please relax your mind and let's see. Once you will do the practice, you can do it easily, okay? So don't get confused. Okay, fine, Bhumi?
Yes, sir.
So actually, you can say this is a little bit difficult question, but when you will solve, when you are successful in solving this kinds of question, then the question that are coming in your board examination will be more easy. Okay, so from here I can say this charge can be in equilibrium, why? Because forces are in opposite direction. So what they are saying now, let's see. A third charge Q is placed on the line joining between the two charges such that all the charges are in equilibrium. Now these all charges will be in equilibrium. Okay, very good. And I should write this also. Placing minus Q charge between 1 and 2. Now the system, all the charges, now all the charges can be in equilibrium. I'm just coming. See, now all the charges can be in equilibrium because the direction of forces are opposite, right?
Yes, sir.
Here all the forces are in opposite direction now. On the charge, this charge, the forces are in opposite direction. On this charge, forces are in opposite direction. On this charge, the forces are in opposite direction. Now all the charges can be in equilibrium
Because they're in the opposite direction.
because forces
Are in the opposite direction.
on the charges are in opposite direction. So one thing is clear from here, we will put the minus Q charge. We will not put the plus Q charge. Okay. So what is the magnitude, sign and position of charge? So can you tell me what is the sign of charge? Answer in answer. Sign of charge. Sign of charge means what kind of charge we are placing in between two charges? Negative charge or positive charge? So sign of charge will be negative, na?
Yes.
Sign of charge is negative because we are placing they are asking what is the sign of the charge. Now there is another thing. We have to find the magnitude and position of charges. We have to find the position of this charge. Please have patience. Sign of the charge is negative. Now I am drawing this again. So what you should do? This is F3, 3 and 2. Okay. What I have done? This is force on charge 1 due to 3. Okay. So now what you should do? We know the distance between the two charges. We have these two charges. Q and Q. And distance between these two charges is R. Okay. And now suppose the charge Q is placed here. We have placed a minus Q charge here. And this charge is at a distance of X from charge at 1. And what will be the distance, Bhumi? R minus X?
Yes, sir. Because the other one's X. Yes.
r minus x. So this was the position 2 and this was the position 3. Was the position 3. Okay, no problem. Now, if for the equilibrium of charge minus q, for the equilibrium of charge minus q, these both the forces should be equal. F31 equal to F32. You can see here is minus q now, and here is F32, F31. F32, F3, and F32 is equal to F31. Okay, so from here can I calculate F32? 3 and 2. See here. So what I will write, K charge Q1 is Q and another charge is Q, and distance between them is r minus x square. And for F31 I am not taking the sign because they are vectors. For F31 this is 3 and this is 1. This will be K Q divided by distance between them is x square. So now let's see, this K cancel, Q cancel, this Q cancel na, and we have only 1 upon r minus x square equal to 1 by x square, and we can write this as x square is equal to r minus x square. So if I take the under root on both the sides, so what will I get? This will become x, this will become r minus x. This is x. So this x will become 2x here when it come here. This will be r. So the value of x will be r by 2. So position, we have got the position of charge. The position of charge will be this. Bhumi, understood? So this x will be r by 2. This x will be r by 2. So this is the position of minus q charge. Now one thing more we have to find. We have to find the magnitude of charge. We have to find the magnitude of charge. We have to find three things. First, we have to find the nature of charge. After that, we have to find the magnitude or position of charge, and after that we have to find the magnitude of charge. Now, for calculating the magnitude of charge, what we will do, for equilibrium of charge at 1, that is Q. So now see the charge at Q. So if this charge Q will be in equilibrium, then F12 equal to F13. F12 equal to F13. So F12 equal to F13. So from here I will calculate F12. What is the F12? 1 into 2. 1 is this and 2 is this. So I can write K Q into Q. K Q square and distance between them divided by IR square. So I can write K Q square divided by R square. And F1 and 3. This is 1 and this is 3. So I can write KQ into capital Q divided by R by 2 square. Can I write now? This distance is R by 2.
R/2, yes.
K Q into Q divided by this. What was the distance? Distance was X, and this X is equal to R by 2. So I can write R by 2 whole square. So now from here, K is cancel out. This K is cancel out. This Q square and Q cancel out. So we will get Q by R square, and here we will get small q divided by, this will be R square divided by 4. Q by R square. This will become, this 4 will go in numerator. 4Q divided by R square. So R square and R square are cancelled. This is cancel out. So we have Q is equal to 4Q, and we have find the magnitude of charge now. Q by 4. This is the magnitude of charge.
But this is the
So,
final answer.
this is the final answer. Means actually we have 3 final answers. In the question, firstly we have to find the nature of charge, whether the charge will be positive or negative. Okay, and after that we have to find the position of charge. Okay, at what distance we should place their charge, so the system should be in equilibrium. And after that we have to find the magnitude of charge. So please note it down, this question, and please have some patience. Okay,
Yes, I wrote this much.
you have written
Placing negative Q charge from there.
from here you want to write. Okay,
Yes, sir.
okay, please write and take your time. Should I scroll down, Bhumi?
Yes, sir.
Okay. We have 7 more minutes.
Yes, I wrote this.
From here, na, you want to write from here?
Yes.
Okay, please write. So you can say this is one of the difficult question of this chapter. Scroll down.
Yes, sir.
Completed na till here?
Yes, sir.
Please note. Completed, Bhumi?
Yes, sir.
Okay. So now we have 5 more minutes, and I think today's class is the difficult for you. I think that because there are
The
the
two
questions.
questions.
Yeah, there are little bit difficult questions, but we should deal with. We have to deal with difficulties in life also. Okay, not the questions, but there can be difficulties in life also. So like this, if you solve some, actually this is not the difficult question. This is conceptual question.
Yes, the theory part was fine, but then these are like tough. But
Yeah.
like
No,
I'll
no, no,
practice it.
no problem. When you will practice, when you will find some doubt, and you can also ask me some doubt whenever there is a doubt. Why this force is going in that in this direction? Why this force is going in this direction? There is reason for everything. Okay.
Yes, so that magnetism and matter chapter I'm studying, it's mostly theory, right? Because our teacher told the same thing.
Okay. In
It's
magnetism and matter, you are
yeah,
only you are only studying the theory part.
no. Our teacher said that like the physics teacher in our school, she told that this is like a scoring chapter because there are less numericals and more like learning things, so you can learn it easily and score.
Yeah, that I think she is correct. In magnetism, the theory is more important, I think. Okay, so we have to deal the chapter as the questions are coming from the examination, according to the questions, according to the questions that are coming in the examination. Actually, I am telling you that this is the, I think, most difficult chapters, these two chapters, like electric field and charges, and after that
The
potential
potential one.
and capacitance. These are, I think, little bit difficult for students.
I did the current electricity, but
Yeah,
that's fine.
actually current electricity is easy one
Yeah,
on this
that's
one.
yeah.
But we cannot leave na, we cannot leave this chapter, we cannot leave na. So
Yes, sir.
we have to study this chapter, but it is difficult, no matter, but we will at least try to study this.
Yes, sir.
And I am telling each and everything, I am trying that you should not feel any difficulty, you should not face any difficulty in any problem. So from here we have, actually all the things are started with charges, and after that charge, positive charge, after that Coulomb's law. Actually we are now only dealing with Coulomb's law. Okay.
Yes.
You should remember what is Coulomb's law. Actually, apart from the theory, try to focus on the numerical also. Okay. And if you have any problem, you can ask me. If you have any doubt, anything, you can ask me. And we will solve the question that have come in the examination, already come in the examination, and we will solve those questions also. So we will get more clarity.
Yeah. Like last year's question papers and all.
Yeah.
Yeah.
So Bhumi, that's all for today. Hope uh, you have understood the concept, maybe not 100% and maybe 60 or 70%. That's
Yes.
fine, no problem. We will try next time.
Yes, sir.
Okay, that's fine. And if you have any doubt, please ask me.
Yes, sir.
Okay. Okay, now you can leave the meeting, and thank you for joining.
Thank